Inverter.
Welcome to ClickMyProject.com. The title of the project is Interpretable Machine Learning for COVID-19, an Empirical Study on Severity Prediction Task. And the abstract of the project is COVID-19 was considered a pandemic by the World Health Organization. Since then, world government have coordinated information flows and issued guidelines to contain the overwhelming effects of this disease. At the same time, the scientific community is continually seeking information about transmission mechanisms, the clinical spectrum of the disease, new diagnosis, and strategies for prevention and treatment. One of the challenges is performing the tests for the diagnosis of the disease, whose techniques adapted for the detection of genetic material of COVID-19 requires equipment and specialized human resources, making it an expensive procedure. We hypothesize that machine learning techniques can be used to classify the test results for COVID-19 through the joint analysis of popular laboratory tests and clinical parameters, which is used to find based on the severity of the patient through the features between the clinical parameters. The machine learning techniques are used to classify the data and predict the results. The machine learning algorithms are decision tree, random forest, and XGBoost algorithm used to classify the data, and also we have enabled the neural network algorithm. The algorithms are enabled that the creation of disease prediction model and to analyze these clinical parameters and to generate the final results in basis of accuracy, precision, recall, and F1 measure. And the flow diagram of the project is, first we need to start the program and select the SARS-CoV-2 COVID-19 dataset. Then we use the dataset and then it applied into pre-processing technique. In pre-processing technique, we need to find only the SARS-CoV-2 COVID-19 features only. Other features are removed in the cleaning process. Then we need to select our independent and dependent model, and then we are going to split our dataset into training dataset and testing dataset. Then it will process it into feature selection. In feature selection, we need to find the k-fold categories of the features, and then it will apply it into the classification. In feature selection, it will find the correlation between the features, then it will apply it to the classification method. In classification, we are using 3 machine learning algorithm and 1 neural network algorithm. The 3 machine learning algorithms are decision tree algorithm, random forest algorithm, and XGBoost algorithm, and 1 neural network algorithm. The algorithms are used to train our data set and predict the result in basis of accuracy, precision, recall, and F1 measure. And then the visualization of the future dependence between the line plot which is used to explain the tabular module of the test classification, like the machine learning and deep learning algorithm classification results. I am going to run my program in Anaconda Navigator Spider IDE. And these are all the features that used in our dataset, and in that we are going to find the constant feature based on our dataset, and then we need to remove duplicate features in our dataset and then make it as a correlated group of some features. And this is the mutual information between the statistic model of our dataset, and in that we are using 3 machine learning algorithm and 1 neural network algorithm. This is the mean value of decision tree algorithm, and this is the mean feature value of random forest algorithm, and this is the mean feature value of XGBoost algorithm. And then neural network algorithm, this is the performance graph of neural network algorithm. This is the last part and this is the accuracy plot. And the result of the machine learning algorithm and deep learning algorithms are the decision tree algorithms gives the results of accuracy is 85% and precision is 0.62% and recall is 0.62% and F1 score is also 0.625%. And random forest provides 83% and precision is 0.66, recall is 0.25 and F1 score is 0.36. And the final machine learning algorithm of XGBoost result is 85% and the precision is 0.66 and recall is 0.5 and F1 score is 0.57. And the decision tree provides the highest decision tree, and also XGBoost algorithm provide a higher results than the random forest algorithm. And the neural network algorithm accuracy is 90% and precision is 0.83%, recall is 0.625%, F1 score is 0.7. And these are all the predictor results of decision tree algorithm, random forest algorithm, XGBoost algorithm, and neural network algorithm based on our actual dataset. And this is the partial dependency graph of leukocytes, and this is the partial dependency graph between the mean platelet volume and leukocytes. And this is the individual conditional expectation. This means local interpretable model agnostic explanation. This is the graph, and we have to check using our patient ID. In that we are using 100 patients. In our first patient is provide the probability is 0.0, so he is positive. He is not a severe patient. And this is the line graphs between the every algorithm. This is the line graph between the decision tree algorithm. It will take the features and provide the positivity. That means the severity between the every features. And this is a random forest algorithm line plot, and this is the XGBoost algorithm line plot, and this is the finally neural network algorithm line plot.